Good afternoon, good evening, or good morning from wherever you're joining us from today. Welcome to a Microsoft Reactor Sydney live stream event. My name's Sarah and I'm the Program and Event Manager for the Sydney and Australia region. Today I'm excited to have back with me Deepak and Nirmal to discuss how to defend against the common types of web application attacks. They will both go into a bit more detail with you in a minute about the topic and just some background on their area of expertise with you shortly. But first, a couple of housekeeping notes. We'll be speaking for about 45 to 50 minutes with some time for questions at the end. However, do send through your questions throughout in the comment section and we'll try and answer as many as possible. Additional links will also be added to the Q&A section throughout, including our survey. If you have time to fill that out, that would be greatly appreciated. And if you'd like to reference back anything from today's session, you can do so straight after today on our Reactive Global YouTube channel. But for now, I will take off my slides and hand the floor over to Nirmal to kick it off. So thank you so much, Nirmal, and over to you.
Thank you, Sarah. Hello, everyone, and welcome to our session on how to defend against common web attacks. I'm Nirmal Thewarathanthri, and I'm part of our Azure Networking and Security Global Black Belt team. Today, I'm also joined by my colleague, Deepak Maheshwari. So first, let's have a look at the agenda and what we are going to cover today. So what we will look at doing is we will have a look at our security portfolio, and then we'll have a focus around network security capabilities. And then what we will do is we'll look at a few patterns. So we have 3 patterns that we want to walk you through, and then explain how customers can take advantage of native security capabilities to defend against common web attacks. So to get things started, I want to talk about the larger security portfolio that is offered by Microsoft. So as you can see in this slide, we have a defense in-depth approach where we have a larger spectrum of services and capabilities that is going to span from identity and access management all the way to network security. So from a network security point of view, we have, again, multiple products and multiple services that forms our network security capabilities on our cloud platform. Specifically to call out, we have Azure Firewall, Firewall Manager, we have Web Application Firewalling, Front Door, DDoS, and Bastion part of the network security portfolio. So moving on, a question that gets asked is, how these services fit into a zero trust security approach, and also whether these components are complementary with each other, or whether we specifically need to pick and choose one component or the other. So the best way to look at this and approach is to think about infrastructure security and application security. So if you look at this slide, I have broken down into infrastructure security, which covers the Azure Firewall, DDoS, and Bastion. And then on the other hand, we have the web application firewalling capability. So absolutely, these components are complementary with each other. And when we walk through the different patterns, we'll talk about how these different components will integrate and complement each other to offer a better security model for customers. The key thing here is to also understand how to approach a layered defense approach, where you have not just one component, but you have from the edge all the way to the application, you have different layers of security and layers of protection applied to your environment. So with that, we also want to look at how real these attacks are. So for that, I am taking reference from our Microsoft Digital Defense Report. This is a public report Microsoft has been publishing each year. So this is the report from 2021. So looking at this particular report, specifically we want to call out the large number of DDoS attacks that the Microsoft security and the cyber defense team have seen over the last few years. And in the past, we used to see these attacks specifically during the holiday season. There's a lot of attacks against e-commerce platforms, gaming platforms. But now with the pandemic and users working from home, what we've seen is an increase in attacks, not just during the holiday period, but in general, we are seeing a large growth in attacks. So in 2021, Microsoft mitigated a 3.4 terabyte DDoS attack, which is one of the largest DDoS attacks, specifically for layer 3, layer 4 type attacks. And then what we've also been seeing is an increase in application layer attacks as well. So that's a 9.89 terabytes app layer attack that we've seen and been able to mitigate, safeguarding customers. So the key takeaway here is that instead of having simply one component, in order to have better security, we need to understand and apply a defense in depth, multi-layered approach for your network security and for your applications. So with that, I'm going to move towards the first sort of pattern that I want to cover. And the focus for this particular approach is really focusing at the edge. So with this, I want to introduce Azure Front Door service and the web application firewalling capability. So web application firewalling capability that we have is, again, it's an application specific attack prevention method where you utilize the OWASP rule set, and based on that, together with a bot protection rule set, you would be inspecting layer 7 requests that are coming in via the edge, and then be able to apply mitigation if there's any malicious traffic that is coming through. So we have a unified WAF component, web application firewall component, that can be applied either at the edge that works together with the Azure Front Door, or this component can be applied at the VNet as well, utilizing application gateway. My colleague Deepak, he will go in and have a look at how this component can be applied at the VNet, where we will utilize web application firewalling together with the Azure Firewall Premium to offer security end-to-end for customers. So with that, I also want to talk about what are the strategies that can be implemented for protecting customers at the edge. So Azure Front Door, as you know, it's the web application firewalling and acceleration capability that we have, and that operates at the edge. So one of the key benefits that customers get by utilizing Azure Front Door at the edge is that we can apply protection and mitigation before the traffic enters the customer's VNet. We also offer caching capability as well, part of Azure Front Door. So together with the web application firewalling, caching, we are able to provide protection before malicious traffic enters a customer VNet. So what are the different strategies? So first one that I had covered on the previous slide is to go in and configure your web application firewalling policies. So we will have a look at a demo shortly and have a look at how some of these settings can be configured. Part of your web application firewalling, we can also apply geo filters, and we can say we only want to allow traffic to be originated from Australia, as an example, or depending on where your customers are, you can have a specific geo filter that can be applied. The other capability that's also part of the web application firewalling, as a custom rule, we are also able to offer rate limiting capabilities. So we can specifically say, I'm only going to accept X number of connections coming from a specific IP. And then the two other items that I mentioned is the caching functionality. This would mean that the edge will absorb all of the connections and the attacks that are coming in, where we can cache the content and service the requests that are coming in, rather than sending those connections to the backend. Because what we want to really focus on is ensuring that the application has uptime, rather than sending all the malicious traffic to the backend, where the backend service might not be able to sustain under heavy load. The third capability, which is offered natively within Azure Front Door, is that the front door will only accept HTTP or HTTPS traffic, which would mean any other payload that goes in, TCP attacks, UDP type attacks would not flow through front door. So we have protocol blocking by default available with Azure Front Door. So with that, I'm going to go to a quick demo and then talk about how we can utilize Azure Front Door and how we can protect customer resources. So I want to walk through a few things. The first thing I want to do is I want to bring in this topology that I have created. So with this particular topology, what we have is we have a user accessing a web application that's hosted across two regions. And then what we have here is we have Azure Front Door deployed. So as I said at the start, Azure Front Door is a global service where we are deploying the resources at the edge. And then from Azure Front Door, we would then use the global backbone network to get to a specific region where the end application is deployed or where the origin is located. So this gives us the opportunity to apply protection and mitigation at the edge before traffic would go in and meet the origin. So this is the topology that I will be demonstrating today. So I have deployed Azure Front Door, and then I have web applications deployed that is going to send all traffic via the Azure Front Door endpoint. So a few things that I want to showcase. The first thing is this is how my Azure Front Door profile looks like. So I have this endpoint here. So first thing I will do is I'll open up a new tab, and then I shall go in to this endpoint just to make sure that the web app is working and functioning as expected. So with that, I also want to go into security policy. So this is where the web application firewalling capabilities are configured. So here, as you can see, I have a WAF policy that's deployed. So once I go into the WAF policy, I have a few capabilities that I can look at. The first thing I want to have a look at is the policy mode. So this is important to understand when you approach implementing security. You also want to understand, based on telemetry, what policies to go in and fine tune. So an approach that a lot of customers would take is you initially enable this in detection mode, so you get an understanding of what kind of traffic flows you have for your application, and then you can switch the protection to prevention mode. So in prevention mode, what happens is traffic will be denied from the web application firewalling rather than logging and allowing traffic to pass through. So as you can see in here, my policy mode is set to prevent. And if I need to, I can go in and switch this to a detection mode as well. And then the key thing here is to go into policies. So these are managed policies by Microsoft. So we go update these policies if we do see any zero-day vulnerabilities that we want to go and protect customers. We would go in and we would go in and update these managed policies. So there are two types of policies in here. The first one is we have this default rule set. So that's an abstract of rule set that is from the OSAP open source rule set. And then there are also rules that Microsoft would go in and inject based on the threat intelligent feed. So here with the bot protection rules, we can also go in and block malicious bots that are constantly trying to attack, trying to search or go in and index your website. So you can go in and do it at the same time for things like search engines. You can go in and allow those connections to flow through. So this is the default set of capabilities we have, a part of the web application firewalling. But now what I want to do is I want to take a next step onto this, and then I want to go in and apply some custom rules in here. So when I move on to my custom rules, as you can see right now, there are no custom rules in here. But what I want to do is I want to go in and apply a few custom rules to my web application firewalling. So let's go in and add a custom rule. And here I'm going to say this is my rule 1. And then, as you can see, I have two types of rules that I can create. I can create a match rule, or I can go in and create a rate limiting rule. So ideally, what you want to do is you want to structure this in a way where you have the first rule to be a geo filtering rule. So you specifically either deny or allow traffic coming from specific regions. So the best way to do it is you can go in and say, I want to, let's say I'm assigning priority 100. And then I can select what type of rule that I want to create. So I'm creating this rule based on the geolocation. And then I have two options in here. I can either say I only want to allow traffic or deny traffic coming from a specific region. So here I can say if there's traffic originating from Australia, I want to go in and deny. Or what I can also do, which is a better way to approach it, I can say, if it's not a part of this list, if it's not originating from Australia, I want to go in and deny all traffic. So based on that, you can determine how you want to apply the geo-filtering rules. That usually the first rule that you would go in and create to mitigate attacks coming from other regions where you might not be having customers. So in this example, I'm just going to say if the traffic is coming from Australia, I want to go in and deny. And you've already seen I am able to go access this website. So I'm going to click add and I'm going to apply this rule. So that's the first thing we've done. We've gone in and added this particular rule. And then once this is applied, we would go in and have a look at how this rule would come into effect in the environment. And then I will also go in and show some of the telemetry and the data that we get to see inside Azure front door. So you can see that the rules already applied. So what I will do is I'll just open up another in private browsing session, and then let me copy paste the same URL, and then I'm going to try and access this URL. So it's working at the moment. Let me try and close this. I'll get a different browsing session opened up. So ideally, once the rule is applied, what you would say is, so this is on a different browser, we can see that the request is now blocked. So if I open up another tab, paste the same URL, you will see that the request is blocked. So that is the geo-filter rule coming into effect and blocking traffic specifically being originated from Australia. So similar to this rule, I can go in and attach a rate limiting rule, and I can say, for 1 minute, you can only add a specific number of requests, and based on that, I can go in and drop traffic based on the rate limiting configuration that I have. So it's all well and good for us to go in and set up all this configuration. The next thing is to really look at, how do we now visualize and understand the data. So for that, if I switch back to my Azure front door view, one of the things that's been added part of the Azure front door premium SKU is that we now have this built-in reporting. So when I go to this security reporting, so this is again built in. You don't have to go set up any log analytics or diagnostics to view this data. And in here, what you'd start noticing is what kind of attacks that we are blocking. So while this loads up, I also want to remove the rule for geo-blocking, because I also want to show you some of the other capabilities that's available in WAF. So let me go ahead and remove this rule that we've just created. And then I will also show you that once the rule is removed, we can now continue to access. And at the same time, I will also show some of the other capabilities that we have part of the WAF rule set, especially if you are trying to do, if there are any SQL injection attacks or if there's any script execution that happens across the for the website, we would use the WAF rules to automatically go and block. So let this complete. And then once it's done, what I will do is I'll switch to the other tab. And then once we refresh, we should see being able to access the website. So once it takes about 30 to 40 seconds for it to get refreshed. And once it's refreshed, we can go in and access the website. But the key thing here is to really be able to look at all the data and the telemetry that we get. So in here, we have a few reports that we can go into. We can have a look at how many requests are being processed by the WAF rule set, how many requests are being blocked, and then we can also look at what are the different types, right? So example, in here, you can see there is a geo block that was placed and there are 3 events that took place. So that's really looking at the 3 times that I tried before or while doing this demo. And you can also look at the different breakdown based on managed rules and also the custom rules that you've added for this environment. You also have all these different checks based on where the traffic is coming from. You can see the region. You can also find out what is client IP. So based on this, you can now go in and fine-tune rules further. And if there are any other adjustments you want to do, so if you are seeing specific attacks being launched from a specific area, you can go in and block those rules and fine-tune these rules as well. So what I did also want to show is in this example, when I go to specific website, you can see this is trying to inject a query string. So based on these attacks, it is blocking, and the WAF rules are coming into effect, and it's going in and rejecting some of these requests to requests going in. So this is the built-in WAF rule sets. So based on where I'm going, it will actually go in and do it. So this one is specific, again, query string request. So these requests are then captured by the web application firewalling, and the traffic is then denied. So that is really the configuration that I did want to show inside Azure Front Door. The other thing also that is available with Azure Front Door is that you can protect your backend origin by utilizing private endpoints. So that's a new capability that's been added to Azure Front Door Premium, where you can go in and reconfigure your origin, and based on the reconfiguration, you can then utilize private endpoints for your backend. So the benefit you get by using private endpoints is that you don't need to go in and specifically open up a public endpoint or a public IP. Utilizing the platform, you can now go in and integrate to these services. So as an example, I'll open up how to do this. So if you click on add new origin, you can then select what type of origin you want to do. So example, I want to do with app services, and then you have this option, and that's available with the Azure Front Door Premium SKU, where you can now turn on a private endpoint or private link service, which will create that backend connection to your resource without the resource needing to be exposed to the internet. So that's a good way to protect your origin without the origin needing to be exposed out to the internet. So with that, I'm going to switch back to my slides, because what I also want to do is I want to talk about the origin sitting in a VNet. So example, let's say you are using application gateway, or let's say you are using virtual machines in a VNet. How do we now apply another layer of defense against these resources that are on a VNet? Because we've looked at how we do this at the edge, but let's also now move our focus to the VNets. So for your VNets, we have Azure DDoS protection standard. And what this offers is a layer 3, layer 4 protection for your VNet. So this will ensure that you can apply your protection at front door at the edge. And then if there are any attacks against the public IP, you can now utilize a DDoS protection standard to mitigate against any layer 3, layer 4 type attacks that are coming in. Part of DDoS protection standard, we also offer rapid response part of it. So there's a 15-minute SLA. So if you are under DDoS attack, you can raise a support ticket, and we would have our support engineers working with you and assisting to provide mitigation techniques and provide assistance in preventing DDoS attacks. The other thing that also happens with DDoS standard is that there's no additional cost for running web application firewalling. So if you have app gateway and the app gateway is configured with WAF, then there's no further charge for the WAF component of the application gateway. So that's already included part of DDoS standard. So with that, I want to go back to my environment, and I want to walk you through how DDoS would work and how the DDoS could be configured. So the first thing you do is you have this DDoS plan that you go create. And then once you create the DDoS plan, what you can do is you can apply it to VNet. And then once it's applied to VNet under protected resources, you will see the public IPs being listed. So in this example, I have an application gateway that's configured with DDoS standard. And then if I go into this resource, I can go to metrics. And then in here, what you would see is that you have now a special set of metrics that would come in to say this IP is protected with DDoS, and then you will be able to find the DDoS thresholds as well. So here I can find out what is the sync packet threshold, and the threshold will be visible in here. We also utilize machine learning and fine-tune these thresholds depending on what kind of traffic that's flowing through. But initially what happens is as soon as you create the DDoS standard plan and apply to your environment, we will look at the backend workload that you're running. So example, if it's 2 virtual machines that's available in the backend, based on that backend, we will apply a default rule. So we'll look at the resource and understand if you have this VM with this particular NIC, how much traffic can it handle? based on that, we would then go in and apply a default set of rules. And these rules can be further customized if there's a specific ask from a customer to provide a specific threshold for these standard DDoS rules. Because the key thing here with DDoS is really ensuring uptime of the application and being able to service legitimate traffic for your customers. That's really the key goal for DDoS. So here I have done some simulation before. We have multiple partners where we can go in and simulate DDoS attacks. A lot of customers do it as well to ensure they have a good DDoS protection strategy. So in this case, we use the Breaking Point Cloud partner who can go in and simulate DDoS attacks against my endpoints. So here you can see in a specific time window, you can see at what time these attacks originated, and then you can see the mitigation pipeline kicking in and then scrubbing all the traffic that is coming in and rejecting all the malicious traffic to the application. So the application keeps up and running where the malicious traffic we've discarded utilizing the DDoS plan. The other thing I do want to show is, putting all this configuration is good. We also want to look at what kind of data we are getting. So for that, there is a workbook that's being created. You can get this workbook applied in your environment. And the workbook will then show you how or what kind of DDoS configuration is available in the environment. And it will also show you what type of attacks that are coming in, whether they are TCP-based attacks, UDP-based attacks. You can see all of that utilizing this DDoS standard report. So it will give you a breakdown of all the different components that we look at by doing the diagnostics integration. So this is essentially taking all of that data from your log analytics workspace and giving you a visualization to understand what type of attacks are being launched against your endpoint. So this will break them down, show you what resources are under attack, show you some of the row logs, and also give you this sort of breakdown to understand what is the origin where some of that traffic is coming through. So as I mentioned at the start, it's really about configuring that different layers of defense against the applications that you run to prevent from common attacks. So with that, I want to hand over to my colleague Deepak, and Deepak will walk us through how to now integrate this further and look at implementing Azure Firewall Premium with the IDPS capability and ensure we have end-to-end protection for the application. So with that, Deepak, over to you.
Sure. Thanks, Nirmal.
Hi, Deepak and Nirmal. We appear to be just having a couple of internet issues from Deepak's side. So we'll just wait a minute or so to see if we can come back and join us. So everyone,
Sure. Yes, Sarah. Can you hear me now?
Yep.
I can. Maybe keep your camera off. It's probably helps with the internet.
Yep, I think that's what I'm
cool.
planning
Thanks,
to do.
Deepak. Over to you.
Thank you.
Cool. All right. Thanks, Nirmal. Thanks for covering two different scenarios and talking about how do we protect our application through DDoS as well as the web application firewall. So I will take it a little bit forward and talk about how do we provide end-to-end TLS inspection. Now, this is something which a lot of customers have been doing it on-prem, and they want to achieve the same capability in Azure as well. So traditionally, what customers generally wants, they want all the web application related traffic can be inspected at the web layer, and all the network related traffic can be inspected at the firewall layer. So anything which is related to intrusion detection and prevention, that should be able to be inspected by Azure or any firewall. So we have a pattern in order to achieve this. So Azure has got Azure Firewall, which can work along with application gateway, which has got the web application firewall enabled on it. This provide kind of a east-west, north-south traffic capabilities in firewall, and it also provides the inbound TLS termination using application gateway. And Azure Firewall Premium also has the capability to provide IDPS, so intrusion detection and prevention, system. So it can detect the intrusion and it can prevent the intrusion as well. So I've got a lab configured, and I'll show you in my demonstration that how does it look like. So to start this first, what I'm going to do is I will actually, connect to my lab environment. And yep. So just to give you perspective and overview of my lab, in the right side, you could see I have got my user who's sitting on internet and he's trying to access a website. In my demonstration, I'm using tactalk.cloud. So I've created a record with web.tactalk.cloud. And now this traffic is going to go through via application gateway. So we could see here, the user will initiate the connection. And this website is basically running on a virtual machine in the backend. And basically the front end is the application gateway along with the web application firewall. Since it's a HTTPS traffic, what will happen, this request would go to web application gateway, and application gateway would decrypt that traffic and will inspect the traffic against any web related vulnerabilities. So any OWASP vulnerabilities, layer 7 vulnerabilities will be, assessed here. And then we also have got a firewall configured in the backend. So I'm using a VLAN, networking topology. And in this VLAN network topology, the traffic will be routed through the secure VLAN hub, which is the Azure firewall. And Azure firewall will basically detect any IDPS related attacks, and then the traffic will be forwarded to backend virtual machine where the actual website is running. So I've got this kind of environment. And to give you the perspective, just to make sure we have got everything configured. So I've got my website, which is web.tactalk.cloud. And if I just ping it, I get this public IP address. And this is the public IP address of my application gateway. So I'll just move this down. And if I come on my application gateway, this is the public IP address of my application gateway. Now, what I also do is, in order to configure my backend, so I have also created something called a listener. And listener is something in application gateway, which basically define what kind of traffic can come in, whether it's the HTTP or HTTPS. And if I look at my listener, I've also configured a certificate on my listener. So I've got the public certificate. So obviously, if it is a website and I'm trying to access it over the internet, I also need a public certificate. So I have got a DigiCert certificate, which is configured and which basically, assigned to my website, tactalk.cloud. So this is my listener, which is going to receive the traffic, going to do the SSL offloading, going to basically inspect the traffic. And then what it's also going to do, it also has got the backend. And in the backend, it is also going to re-encrypt the traffic. So since we are talking about end-to-end SSL, which means the traffic will always be encrypted. So when the traffic passes through the application gateway and web application firewall, it basically gets decrypted, scanned, and then re-encrypted before it goes further. And now with this, certificate in the backend, we are re-encrypting the traffic. So all the traffic which is going to go to my backend is now encrypted. So this kind of, shows that I have got the, end-to-end SSL or TLS inspection enabled on the application gateway side. Now, just to look at my web application firewall, because I also have got a web application firewall, which I've also configured in the prevention mode. So the web application firewall is configured in a prevention mode. And what does it do? Basically, it will drop any malicious traffic. So if a user is, trying to connect, or if the traffic is malicious, the web application firewall will drop that traffic. So if it finds that attack is part of the OWASP vulnerability, then it will detect that traffic and it will prevent that traffic to going forward within the environment. So in order to simulate this, what I've done, I'm going to use one of the directory attack. So it is basically a path traversal attack. And path traversal attack works in a way that behind any URL, if you just put this as string. So what it is trying to do, it just goes, try to look into the root and tries to enumerate the directory and look for the information. And if I do that, my access to the website will be removed. So if I don't use it, that's fine. I'm able to access my website fine. But if I use that URL, I would not be able to access my website because I have actually stopped that traffic at the web application firewall level. So if I just do it again and look at it, it just says 403 forbidden because the application gateway has discarded that traffic. Now, if I want to see that, what I can do is I can basically go back to my application gateway. I've also configured my application gateway to log all the events to the log analytics. And if I go to my log analytics, and if I look at my queries, and if I run my query, and maybe I'll just change it to last 30 minutes to make it faster. It is basically going to look at if the traffic is malicious and if it is part of the OWASP vulnerability. And yes, I could see the traffic is coming. That's my IP address. So like, I'm connected right now and it basically looks to that match and it shows that it just matches with the OWASP rule set. And this was added in the request URI and the traffic was basically dropped. So it kind of like, denied the traffic to go forward and dropped it at the web layer itself. So that kind of confirms my website is working. If there is any legitimate user who's trying to access the website, it should all work fine. Now, what about a scenario where somebody is trying to have a different kind of attack? Maybe they're trying to use, IDPS or intrusion, type of attack. So in that case, we also have got a firewall in the backend. So as we talked about, right, we have application gateway, which is basically going to, re-encrypt the traffic once it leaves the application gateway. Now, since we are using the vWAN environment, our traffic between all the virtual network is routed through the vWAN. And we are also using the secure hub. And secure hub basically allows all the traffic, can be inspected within the network. So I have got a firewall running in my vWAN environment, and I have configured the firewall policy, and I've also uploaded the certificate, which will basically allows to decrypt the traffic, which is coming from application gateway. And then it will basically re-encrypt the traffic again and forward it to my web server. So to look at that one, I will just go and look at my virtual WAN. And so this is my virtual WAN. And if I look at my hubs, so I've got only one hub because I'm connecting to virtual network. And this hub is basically a secure hub because I've got a Azure firewall running on this hub. So if you see this icon that shows Azure firewall is, configured on this hub, and it is a secure hub. Now, to enable the routing between the network, I have actually peered these virtual network to my hub. So if I just go back and look at my virtual network connections, I could see I have got my virtual network where my shared services like application gateway is hosted, and I've got my other virtual network where my application services like my certificate server, my web server is hosted. So these two are connected. That means I have got a peering enabled, and I should be able to communicate between the virtual network, and the traffic would be routed through the firewall. Now, in order to configure my firewall, what I've done is I have got my Azure firewall, and Azure firewall actually requires a policy to be configured. It's a premium firewall, which means I've got an Azure firewall policy as premium. And in that premium policy, I have configured my IDPS. So now all the traffic is going via the firewall, and I have configured my IDPS configurations in alert and deny mode. So it's up to you. You can change it to alert if you just want it to be alerted and you don't want the traffic to be dropped. But in my case, I want to, secure against any intrusion or any suspicious, activities. So I've selected alert and deny. In this case, the traffic will be denied. Now, in order to make TLS inspection work, because be mindful of the fact, if your traffic is encrypted, we cannot look at the vulnerabilities inside the packet. Now, in order to look at those vulnerabilities, we would need to open up that packet. Now, in order to open that packet, we need the certificate. So, because it's end-to-end TLS encryption, which means traffic is getting decrypted and encrypted at each endpoint where it is passing through, and we also need to inspect the traffic. So in order to make this work, I also have got my subordinate certificate. So that's something which I have actually acquired from my Active Directory certificate services. In this demonstration or in this lab environment, I have deployed a Windows Active Directory certificate services. And I have created a subordinate certificate, which basically allows you to generate certificate, on a certificate services behalf. So that's the certificate I have applied, and I've also applied that certificate. I have also saved that certificate on a key vault because it picks up the certificate from a key vault, and that requires a managed identity. So you need to provide access to your managed identity to retrieve the certificate. And this is what is configured. And if I quickly go back on my key vault, and if I look at my certificates, so I have got my two certificates configured. So the first certificate is my public certificate assigned by DigiCert, and that allows me to put that certificate on a application gateway, and that's going to do the SSL offloading. Now, this is the certificate for that one, and the another certificate is the subordinate certificate, which I've acquired from my Windows Active Directory, and that's saved there. And I also have configured my access, which means only the managed identity can access the certificate. So if I look at my configurations and if I look at my access policies, this shows I've got the application, which is the managed identity. It only has got get and list access to the certificate because the certificate is saved in the key vault, and my Azure firewall is picking up this certificate from a key vault. Now that's all good. And if I want to look at my certificates, so I'm using the Active Directory certificate services. And if I look at my certificate, which I've exported and imported in my key vault, that's my subordinate certificate. So I've got a subordinate certificate, which is configured. And in order to make this all work, so what I've done is if I go on my certificate services, so I have configured my subordinate certificate template. So I'm using this subordinate certificate template in order to basically, this certificate template is allowing me to request for this certificate. and export the certificate and upload it in my firewall, because this certificate is allowing me to generate the certificate from Azure firewall. Now, that's all good. And if I just go back and let me just have a look at my firewall policies one more time. Yep. So I've saved that certificate here. And what I've also done is I've also created the application rule. So you could see I have got the certificate here, and this certificate is coming from my keyword. And this certificate is basically, allowing the traffic to be decrypted and then re-encrypted and forwarded to the web server. Now, if I look at my application rule, because I've got a firewall, which means by default, it's going to block all the traffic which is passing through the firewall. And I will also need to configure the firewall rule. So Azure allows you to configure the firewall rule and also gives you the capability to enable the TLS inspection. So if you look at it here, so we have got the TLS inspection enabled. And what I've done is I have actually configured all the traffic which is going for my backend. So my website is, VM-web server 1. That's where my website is running. All the traffic going to that direction should have the TLS inspection enabled. Since I've also enabled the TLS inspection, all the traffic will be inspected, because now the traffic will be, decrypted, look for the vulnerabilities, and then re-encrypted, and will be forwarded to the backend application. So what happens if I try to create some sort of attack? So what I'm going to do is I'm going to generate an attack, and I'm going to look for that attack and look for my logs, that if my logs picks up that attack. So I'm going to use the vulnerabilities as hexaman, and this basically generates the malicious traffic, and this is going to generate the malicious traffic from my website. And if I try to do it, I won't be able to access my website, and I should get the error message. So from my machine outside of my firewall network, I'm trying to access this website, which should ideally work fine if I'm not using the hexaman. And then I get the gateway timeout error message. So it gives me kind of error message that I was not able to access the website. Now, let me just go back and look at my logs. So if I go back on my firewall and so if I look at my queries, this should load up. That's fine. What I'll do is I will just run the query manually. So I've enabled the diagnostic logging for my firewall, and I'm gonna query the logs related to IDPS, and I'm gonna look at my window for last 30 minutes. And here, if I look at it, I can see the request coming from my application gateway. And this kind of matches the signature rule. And I could see the traffic is kind of potentially a bad traffic. And then bad traffic is basically, denied. So what firewall has done, it basically dropped that traffic and didn't allow that traffic to go through. So this kind of confirms we've got the traffic coming from a user is getting inspected on a web application layer and also getting inspected on the firewall layer. And on all the layers, the traffic is fully encrypted, because the moment it goes out of the web application firewall to the Azure firewall, it is encrypted, and then it gets decrypted, and basically it get scanned through for vulnerabilities, and then only the traffic goes back to the backend. So this kind of concludes and confirms that with Azure Application Gateway and Azure Firewall, we can have end-to-end TLS inspection enabled. Now with that, we are actually reached to the end of our session. So this basically kind of confirms that we have got the protections available at different locations. So in terms, when we look at the security, it's kind of a shared responsibility, because as a cloud platform, Microsoft is responsible for protecting the infrastructure. So anything related to virtual network, it's all protected by Microsoft. And Microsoft also provides the tools for users to apply those protections to protect their applications. So things like, if you've got PaaS applications, platform as a service, you can use Azure Private Link. If you've got web applications, you can protect it through the web application firewall. If you want to protect any network-related services, you can use Azure Firewall, Azure DDoS protection, as well as Azure Bastion. So with this, we are almost at the end of our sessions. So there are a few useful informations and link we would like to share with you. So in case if you have any questions, we still have got 5 minutes left with us. Feel free to post your questions in the chat window.
Great. Thank you so much, Deepak. I've also just added Nirmal back to the conversation. As Deepak just mentioned, we do have a couple of minutes left. So if you want to ask any questions, you can do so now in the chat section. So get those questions in there. Whilst we're waiting for any last minute questions to come through, I'll just remind everyone those links that you can see there on the screen that Deepak was sharing are available all in the chat section there. So every link you need for today are in there. Also, on top of that, we've also got our link to our Reactor Sydney meetup page, where you can check out any upcoming events we have, some both in person here at the Reactor in Sydney and mostly online, and also some with our global team with the reactors around the world. And we also have our Reactor YouTube channel and a link to today's on-demand version. So if there's anything you'd like to reference back, you can do so on that Reactor YouTube channel, and a link to our survey with the event code 17558. Looks like you have both, Deepak and Nirmal, answered all questions throughout your presentation. So thank you very much for your presentation and also your demos today. They were really interesting and informative. And thank you to everybody for joining us as well. I think we'll leave it there. So thank you so much, Deepak and Nirmal.
Thank you all.
And yes, whoever just asked us in Zoo in the comment section, yes, the session's recorded and it's on our YouTube channel. So all the links are available there in the comment section. And thank you to everyone else who joined us. Have a good rest of your afternoon, evening, or morning, and we'll see you next time for another Microsoft Reactor Sydney live stream event. Thanks both.
Cool. Thanks, everyone.